Here, we're going to go through all 4 steps for a 2-proportion hypothesis test. We're going to compare 2 groups. Our example says a GPS company is interested to know if there is a difference between the number of men who text frequently while driving and the number of women who text frequently while driving. As a guideline, the company declares that texting 7 or more times per week is classified as frequent texting. Suppose we take random samples of 500 women who text while they drive and 650 men who admit to texting while they drive. We find that 140 of the women and 220 of the men text frequently while they drive. So they don't just send a text every now and then, but they send 7 or more texts every week. We want to know, can we conclude there is a difference between the number of men and women who text frequently while driving? We're going to use 0.05 as our significance level right then and there. For the final step, I know that 0.05 is my alpha. So to go through my steps, step 1, I need to give HO and HA. HO assumes the 2 groups are equal. So I'm going to say PW for the women's group is equal to PM for the men's group. I'm assuming that men and women are equal in texting frequently. One group doesn't text more than the other. For my alternative, well, I want to know, can I conclude there is a difference between these two? So it doesn't say that the women text more frequently or the men text more frequently. That's just that there's a difference. That indicates that we use the not equal to symbol. Right? So these are my 2 hypotheses. Either the proportion of women and men is the same as far as texting frequently goes, or there is a difference. One group texts more than the other. For my second step, I need to check the central limit theorem for the components that we care about at least. I can say that I do have random samples. It says right here that we're random. For my women, my success number is 140. 140 of the women said, yes, I text frequently while I drive. For my failure number, I know there were 500 women. If 140 said yes, I can take 500, subtract 140, and that gives me 360 that said no, I do not text frequently by that standard. Both of these numbers are over 10, so that group is met. For the men, my success number is 220. So that's 220 of the men text frequently while driving. To get my failure number, I'll take the 650 of the sampled men, take away the 220 successes. That gives me 430. 220 and 430 are both over 10. That condition is met. This means I get to use the properties of the normal distribution. Z-scores apply, p-values apply, all of those things apply. And when you're dealing with 2 groups, a 2-proportion hypothesis test, 0 is always going to be our middle number, because if they're equal here and we're focused on the difference, if it's 40 and 40, well, 40 minus 40 is 0. If it's 70% and 70%, 70% minus 70% is also 0. As long as they're equal, you're going to get 0 every time. For my third step, I need to find my z-score, my p-value, and I'm going to get 2 sample proportions, one for the women and one for the men. To do this, I go to Stat, Tests, and it's number 6, the two-proportion hypothesis test. For my first group, the women's group, I had 140 who text frequently while driving out of 500, my sample size, my N. For the men, for my second group, it would be 220 for the X, and it would be 650 for the N. And the symbol I need is already selected. It's a not equal to, because it didn't say one was greater than or less than the other, just specify that there was a difference. So when I calculate this, my z-score is negative 2.12 if I round to 2 places, so negative 2.12. My p-value is 0.0341. P hat 1 for the first group for the women, that is 0.28. And for the men, it would be 0.34. So it seems 28% of women text frequently while they drive, and about 34% of men text frequently while they drive. So the difference between these two is 6%. There's a 6% difference. So that could be a negative 0.06 down here, or it could be a positive 0.06 up here. Depending, do you say the 0.28 minus the 0.34, that will be a negative, be on the left, or 0.34 minus 0.28, that would be a positive one, right? So you're getting two tails here. Together, these two tails, these two sections give you the p-value of 0.034. Now to decide, are they equal in how much they text? Frequently or not frequently? Or is there a difference? We need to use our p-value to decide this. Now we do have a difference here, 28% and 34%, but is that gap, is that difference large enough to say that we have a difference? Or are they close enough to say that they're pretty much equal? Because I might take another random sample of both groups, and I might get 29% for one and 30% for the other. Well, that's not a significant difference. That's not going to say that one group is texting more frequently than the other. But I'm not sure about 28% and 34%, so I'll go to my p-value. In this case, my p-value compared to my alpha, my p-value is 0.0341. My alpha is 0.05. My p-value is less than alpha. 0.03 is less than 0.05. The zeros are the same, but in that second spot, the 3 is less than 5. When that's the case, when the p-value is less than alpha, we will always say that we reject HO. So we're rejecting the idea that they're equal. This seems to show that there is statistical evidence that women actually text less frequently than men while they're driving. 28% is statistically significant less than 34%, so there is a difference. So I would say, and I'm not going to write this out because I'm out of room, but I would say the data are statistically significant to conclude there is a difference between the number of men and women who text frequently while driving. There is a difference. We could go on to say it appears that men appear to be guilty of texting frequently more than women.